Okay, we're on. I got the thing to come on. Oh, now here we are. Oh, I didn't want to go here. I wanted to go over here. All right, so F equals ma. When does the dummy experience the force? Well, there's all kinds of forces going on, like there's his hands touching him here, the frictional forces holding him, being able to hold him up and then throwing him down. But when he hits the floor, did you see how they bounced? Okay, then how does the Newton's second law explain that? Let's take a look at the notes here real quick as we take a look at that. If so, here's the body. Let's say okay. Here's the body all akimbo. Okay, getting thrown down. He threw him down because he was able to twist him and whip him around like that. He was falling much faster than mg. He had an initial velocity, and then gravity took over of being thrown down. So he was going much greater. His acceleration is much greater than gravity as he's going down. And then bam! Hits. Oh! Oh! Ouch! Ouch! All right, so it hits. And now notice the velocity right here had an initial velocity coming down, and then the final velocity is equal to 0, but it actually bounced back up a little bit. Let's say he was coming down at 14 meters per second, and then bounced back up. Final velocity and this was negative. Final velocity is like 2 meters per second, positive, bouncing back up. All right, then the acceleration would equal 2 meters per second minus negative 14 meters per second over how long do you think that collision lasted with the mat? Maybe a tenth of a second at the most. So let's divide that by 0.1. And so look at this. We got positive 16 meters per second divided by 0.1 seconds equals 160 meters per second squared. That's the acceleration for that split second. That's a huge amount of acceleration. Let's say it's a typical man of 100 kilograms. Wow. We get 16,000 newtons of force when we do that because we take F equals ma. Now, I did a thumbnail thing. I can't remember what the actual answer is that they hit the ground. I think it's like 2,400 newtons, so I kind of messed that up a little bit. But maybe the collision time was 1 second or something like that. But it's a tremendous amount of force. But that's the idea, is that this is where the force takes place. Okay. All right, now you're going to watch some of the things on drag racing, okay? And you're going to find out F equals ma. To accelerate the car applies a force of 500 pounds to her. What supplies the force to accelerate the car? Ooh, that's a good question. Do we talk about it in the next slide? Heck no, because we're almost done with this, believe it or not. So again, the force, and then we'll look at the actual homework. Force to get, oh, sorry. I'm kind of in my own world here. Own world. He's doing his own world thing again. So here we are. Force to get wheel turning. It's actually a static frictional force. Here's a wheel. For a split second, the velocity at the bottom of the wheel is equal to 0. The velocity up here, if it's going this way, if it's rolling this, say it's going in this direction, is 2v, and the velocity of the axle is actually v. But right here, for a split second, it's 0. Okay? Right there for a split second, it's 0. The wheel is pushing this way. The wheel is pushing this way. Force of the wheel on earth, on road. And then, but remember, F equals ma, we're talking about the mass of the actual object that we want to move. The thing that's moving then is this, which is the force of the earth on the wheel. And that's what gets it to go. And that's a static frictional force, which equals the static frictional force, which we'll talk about later. It's the force that where things stick. Keeps things from moving. Okay? I kind of went off there. That's a little bit advanced, but when we actually get to the homework, you'll see, oh, well, this isn't bad. This isn't bad. All right? So we're going to stop